But for those of you who don't know me, I'm Michelle de Blasio, and I'm the Watershed Restoration Coordinator for the New Jersey chapter. I will be your host this evening. And tonight we wanted to take you on a behind the scenes tour of the Paulin-Skill Watershed, which sits in Northwest New Jersey, to showcase some of the freshwater work that's going on the ground in this area and to demonstrate how we are collecting scientific data in collaboration with a variety of stakeholder groups to document project impact and determine conservation success for this region. And so I'm really excited to highlight and share our work with you all tonight. But tonight also welcomes the opportunity for all of us to discuss how science is incorporated into different work in different regions. And so following my presentation, we'll have time for Q&A, and then we'll transition into breakout groups, depending on how many folks are on the call. I currently can't see how many participants, but if it's a small enough group, we might just stay together and have a nice group discussion. We'll kind of see where we're at the end there. And so before we begin, we have two quick polls. We wanted to get a better sense of who's on the call with us today. So if we could go ahead and launch the first poll. So what's your role at TNC? I've already mentioned I'm the Watershed Restoration Coordinator here. We'll give it just a few minutes for everyone. Okay. So it looks like we're all in that conservation realm, scientist realm, which is as to be expected for the global science gathering here, but it was good to just get a better sense. We have one more quick question for all, just to get a better sense of where everybody's coming from, tuning in from tonight. So where do you work? Where you currently have all of your projects going on the ground? I actually am in the Paulin-Skill Watershed. I live on one of TNC's preserves. It's right off of Kittatinny Ridge, kind of near the Appalachian Trail. So I am in Northwest New Jersey in Stillwater, for those who are familiar with New Jersey.
I don't see a global option. I'm working on one of our global teams. I'll just do New Jersey area for now.
Perfect. This was really hard, to be honest, to put everything. I actually only had so many options that I was allowed to put in. So I kind of consolidated by just the main ones we all were most familiar with. But okay, great. So it looks like a lot of folks are from the Northeast, so maybe you're more familiar with the landscape here, and it's really great to see a few others from across the sea there. All right. So again, we'll have time for Q&A at the end of the presentation, but feel free to pop in any questions to the chat throughout. We'll have somebody, we'll go through those at the end, or we can just, take yourselves off mute and go through those as well. So let's go ahead and get started. Okay. So my slides are not working. Here we go. All right. So again, I am Michelle de Blasio. I'm the Watershed Restoration Coordinator here. And in my role, I specifically help with a lot of the on-the-ground projects. So a lot of our floodplain reforestation work. And I also help to oversee our water quality monitoring program in the Paulin-Skill. And I've been involved in this Paulin-Skill program and the water quality monitoring program since the beginning of 2015. Which is coincidentally right around the same time that our freshwater program came to be here in the state. And so over the years, I've had this really unique opportunity to watch both this freshwater program grow, but also this Paulin-Skill program evolve over the years. And so today, I wanted to bring you all into the river and leave you all with a better sense of how we're collecting scientific data to document conservation success in this region. But before we dive into the river, I wanted to provide a little bit of context on New Jersey. And so when most think of New Jersey, we often think of this, very densely populated state, highly urbanized, which we are. New Jersey is home to over 9 million people. And although we're very diverse in both our people and our wildlife, I always like to highlight that we're also pretty diverse in our landscape. And so you can see here on the map all the red areas. These are all of our urban lands. This is right outside of Manhattan. This is outside the Philadelphia region. But New Jersey is actually about a third of our landscape is in agricultural lands. We are considered the Garden State. And we also have about another third of our state is in forested lands. So up here in the northwest corner, this is where the Kittatinny mountain range is, where the Appalachian Trail runs through. This is our Highlands mountain region. This area provides a lot of the drinking water for the residents here in our state. Down south, we have the Pine Barrens, which is also a heavily protected forested land. And then New Jersey is uniquely situated in between the Delaware River Bay system, the Hudson Bay system, and the Atlantic Ocean. So we have abundant wetlands and rivers and lakes and streams. And so when we start to think about, how we can conserve our resilient lands and waters here in the state, we really need to think about, what's happening in the landscape. And what can we do to improve these water resources? What are the biggest impairments? And more than 85% of our rivers and streams here in the state are polluted. And they're polluted due to the normal culprits that we see around the globe. We have stormwater runoff, pollution entering our waterways from our farm fields. We have excess nutrients. We have leaky septic systems in our lake communities. We have most of our floodplains have been deforested and left without trees, and trees, as many of us know, play a very important role in protecting our water resources for both people and wildlife. And furthermore, there are over 1,700 regulated dams that are scattered across the 18,000 miles of river and streams here in the state. And that's just speaking to the regulated dams. So there's, we don't even have stats on all the unregulated dams. So having this, disconnected aquatic connectivity, it leaves a lot of our local streams, without these migratory fish populations, and our local streams are actually, our local streams and our local fish, mussel, and other aquatic species are confined to these smaller stream segments in between the dams that polka dot our waterways. And so we recognize that, there's a lot to do in New Jersey. We have a lot of polluted waterways, but we recognize that if we really want to move the needle in terms of improving our freshwater resources, we really need to make a strategic investment, and we really need to work in a defined area or a defined watershed. And by working in a defined watershed, that would actually allow us to, make a difference to water quality, as everything that, happens on that landscape is going to drain to one central river or one central point. And so what watershed? We got down to the strategic planning process and the prioritization process, and we started to look into different models and different tools to determine which watershed we should begin to make our strategic investment. So we incorporated things like TNC's floodplain investment tool, where we looked at specific models that looked at watershed condition, where you can see here in this map, we have, some areas that are in, total natural cover. These areas would be great for, sorry, excuse me, I'm having internet troubles, so give me just a moment. I'm gonna just stop my video just in case. Okay, so sorry about that. So you can see here, in the northwest corner, we have an area that is in just a little bit of, we have a little bit of natural cover, but we have a little bit of area that's not in natural cover. And we also look, so areas like this is where we would probably implement more of restoration, whereas an area where there's, no natural cover, which is pretty predominantly, impervious pavement, can't really move the needle too much there. These areas are really shining for where we would maybe implement restoration work. The areas that are in natural cover are areas that we would implement protection work. We also looked at the Northeast Aquatic Connectivity Tool. You can see here on this map, we looked at, where are there priority dams where, if removed, it would give us the highest ecological gain. If removed. And so we started to, just looking at these two maps, we started to quickly see that this northwest corner actually had areas that, the watershed condition could be improved. We had areas that had high priority dams, and so that area was the pollen skill. And as many of us know, it's all well and good, and we have this priority area that we want to work in, but you can't really get anything done without the funding. And fortunately for us, there was this really big initiative happening in the Delaware River Basin called the Delaware River Watershed Initiative, where a number of different project partners working in the headwater tributaries of the Delaware River Basin, so all the 4 states that border the Delaware, came together and started working as this giant collaborative with an overarching goal to improve water quality in the Delaware River by working and implementing conservation projects on the ground in these headwater tributaries. So TNC, of course, the New Jersey chapter, we signed ourselves up. We started working with a number of different project partners in these tributaries. And we started to see a lot of funding come through to get some of these projects up and off the ground. And so for the last 5 years, with this little bit of seed money and things have evolved over time, we launched this Good to Great initiative. And so the Good to Great initiative was really designed based on the fact that the pollen skill, it's not so far gone like some of these really highly urbanized areas that you see in the neighboring watersheds, but it's also not as great as some of these protected watersheds that we have to the north of us. And so by implementing the right mix of conservation work on the ground, we could really begin to move the needle in terms of freshwater water quality improvements. And so I just want to orient you to the watershed here. Again, this is the watershed boundary. We're in Northwest New Jersey. The Pollenskill is the 3rd largest tributary to the Delaware. And in the headwaters here, we start in the town of Newton. We have our hyperhumus wetland restoration project. As you begin to move north downstream, you start to see all these orange blobs scattered across the watershed. Those blobs represent all of our floodplain reforestation project sites. To date, we've planted over 58,000 trees throughout this watershed. As you move downstream, you can see there's a number of priority dams that we are working on removing or have already removed. So down here at the confluence with the Delaware, we just successfully removed the Columbia Dam, which sat about a 1/4 mile upstream from the confluence with the Delaware. And then furthermore, this purple boundary line, this is where we've been protecting key intact forest land, which serves as a terrestrial corridor for wildlife, which connects the Kittatinny Ridge, which is up here, to the Highlands Mountain region down here. So we've been really busy in this watershed, and this is great. We've been, putting a slew of projects all in one watershed, but our overarching goal is to improve water quality. So what we did with our pollen skill program is we embedded a 10-year measures and monitoring program. And so you can see here, we have all of our different project sites, but now we have about 23 different sampling locations where we're collecting water quality data at each of these sites. And so we have, a site downstream hyperhumus, we have one upstream within and downstream our large reforestation corridor. We have up and downstream our dam removal sites, and then some of our bigger restoration projects like the Columbia Dam project, we have, very heavily concentrated monitoring. And then these points out here, which are on our tributaries, those are, designed to collect baseline information about, the quality of the water that's coming into the main stem to help guide future, management decisions. If we find ourselves, a water quality issue in the headwater tributaries, we can begin to implement conservation work there as well. And so measuring, water quality is a pretty, it's a pretty big endeavor. And so you really need to make sure if, your goal is to track changes to water quality improvements, that you really are collecting the right information that's going to speak to your projects. And so there's a million different parameters and different data points and different things that you can collect when it comes to water quality monitoring, but we focused in on just a few key ones that we felt would speak most closely to our projects. So temperature, we're looking very closely at temperature. Temperature, just like all living, all living organisms in the stream, they require certain thresholds for survival and reproduction. And what we see in our state data sets is that most of our streams are just, the temperatures are really impaired and they don't actually meet the criteria to host and provide good quality habitat for a lot of our trout, our trout producing streams. And so what we're hoping to see over time with our different restoration projects, like our tree planting projects or our dam removal projects, that will begin to decrease our water temperatures to more optimal levels that will be suitable for fish and other aquatic organisms. This photo right here is actually one of our older reforestation sites. And so you can already start to see that our trees are they're already starting to shade the river. And so again, over time, it'll take a while, but over time, we're really hoping to see, what are the baseline conditions now and how are those going to change over time and, decrease over time. We're also looking at dissolved oxygen. Just like we see temperature impairments, we also see dissolved oxygen impairments. Dissolved oxygen, as we all know, directly affects species survival. Just as we require oxygen to breathe, so do the species in the stream. And so a lot of our sites are impaired for DO. They have these very low concentrations of dissolved oxygen. This site right here is the hyperhumus wetland restoration project site. You can see from the past peat mining practices that historically went on at this site, where they channelized and ditched and drained and just kind of made a hydrological mess, if you will. You can see that it's very stagnant. There's no oxygen, there's no flow. And so over time, with the wetland restoration work that we have designed and will be implementing in the coming years, we hope to bring back some sinuosity to the stream, add in some riffles, runs, and therefore increase the dissolved oxygen levels to more suitable concentrations or suitable levels to support aquatic life. We're also looking at turbidity, both within our reforestation corridors and throughout the watershed. We have eroded stream banks, which causes excess sedimentation and therefore high turbidity levels. As those trees grow and the root systems begin to start to hold in the banks, as you see here, these eroding banks, we're hoping to decrease turbidity within those reforestation corridors, but also with our dam removal sites, where the dam that blocks all the sediments that should be moving downstream, they are creating behind the dam these sediment sinks. We're hoping that over time, we will be able to release that sediment and start to see more optimal turbidity, less turbidity within these stream reaches around our dam removal sites. Connectivity is something that we look at to collect baseline data. A lot of the neighboring watersheds, we see very high connectivity levels, which is mostly due to heavily salted roads in the wintertime, which causes your connectivity levels to spike. We don't see a huge issue in our data at this moment, but we are keeping an eye just to see, what the baseline conditions are, and if we, should be looking into that for a future impairment or a future practice in the future. And then last, but certainly not least, we have our macroinvertebrates, which I find to be the most fun, where we are collecting and looking at the macroinvertebrate community. Every year, certain species cannot survive in heavily polluted waters, whereas others can, really thrive in polluted waters. So by looking at the species composition from year to year, we can start to see, we can start to have indicators to water quality just based on the species that are living there. I always, like to show this map. This is actually our results from the very first year of our data collection for the macroinvertebrate and the stream habitat assessments. And you can see that we have, very low or poor or fair scores downstream of our really large wetland restoration projects. We have pretty fair, poor scores near our reforestation corridor. But then the rest of the watershed, we have, good to excellent scores, which very, aligns very nicely with this idea of a good to great initiative. We weren't seeing anything, too terrible, but in the areas we were, that's actually where we have proposed most of our restoration work. So again, over time, we're hoping to continue to improve these macroinvertebrate scores from, fair to good, and then the good ones to excellent. And so just as there are a million things to measure, there's also a million ways to measure and to collect this information. And so, the macroinvertebrates are fairly straightforward and they require little to no equipment for data collection. But the temperature and dissolved oxygen and conductivity and turbidity, those all require a little bit more equipment and technical savvy, if you will, to collect. And so we use different methods for collecting this information that I wanted to go over with you all. And so when we first started this program, we started out with discrete sampling. And discrete sampling, although it was great and we were really excited and we were in the river, we were getting data, it really is limited in that it only allows you to collect a certain data point and a certain place at a certain time. So we could really, by the end of the first year, we realized that we could really only say what the temperature was on that one day at that given time. And if we really wanted to track project impact and pre-post project conditions, we were going to need a lot more data if we wanted to not only show the impact from our projects, but also understand what the baseline conditions are. So what are those monthly summer temperatures? What are those maximums? What are the minimums? So we really needed more data than what this was allowing us to do. So by the end of the first year into the second year, we quickly transitioned into continuous in-stream monitoring. And continuous in-stream monitoring is just like discrete sampling, where you're collecting temperature, conductivity, any one of these parameters. But now the meter is actually sitting in the stream, collecting this data at a set interval. And so we use two different meters. We use OTT's HydroLab HL4 multi-parameter sonde, which has temperature, turbidity, conductivity, and dissolved oxygen all on one meter. We have 4 of those. Those are strategically located near the Columbia Dam removal site. And then we use Hobo's onset U26 dissolved oxygen logger, which collects temperature and dissolved oxygen. And we have 12 of those that are stationed throughout the pollen skill. And so by, putting these in the system, we were then able to collect data every 15 minutes for about 6 months out of the year, which is, really the key time period that we're looking in. So we pull them out in the winter. And so now we were able to really say, we were able to begin to start to make those baseline conditions more real. So we were able to see what our average stream temperatures were, what our mins were, what our maxes were. But it doesn't come without a cost. So as great as this was, and as excited as we were to get our hands on a really robust data set, we realized that these loggers take a lot of babysitting, if you will. That you can't really just throw these in the river and walk away. And sometimes you can't even get in the river to even check them or calibrate them or get the data off them. So we experienced over the years that although it's great and we get a lot of data, they really aren't that efficient when it comes to collecting water quality data. You can have floods, you can have, some days we go out there and they're on the side of the stream bank. Some days there's not enough water to even cover the logger. So we've definitely, it hasn't come without its challenges. So as we began to take on more projects and more work, we started looking into other ways to collect this information that would be a little bit more efficient. And so recently we transitioned into remote sensing, which allows us to not only have a sensor in the river year round, but it allows us now the capacity to look at the data live online through online data systems or data portals remotely. And so fortunately for us, these sensors can be, cost anywhere upwards of $8,000 on the market. Fortunately for us, one of our partners in that Delaware River Watershed Initiative, the Stroud Water Research Center, had begun making these remote sensing stations for partners working in the Delaware River Basin. And so in 2017, they began giving these remote sensing stations away. And so essentially, this is the data logger here. And the data logger sits inside this housing box here, where you program the data logger to speak to the online software and then communicate with the data portal online. And so we were really fortunate, but this program really took off over the years, where they are now actually selling these remote sensing stations. Because it was such an instant hit in the basin, they really transitioned the giveaway program to a more hands-off approach. So we actually just recently last year participated in a training where we put the data loggers together and programmed it, and did the online transfer and set everything up. And once it's all programmed and speaking to the computer and the online data portal, you go out into the stream. The logger itself sits on this PVC pipe, which you drill or hammer into the stream bed. This is the sensor itself, which connects to the communication cord, which goes up to the data logger here, which is recording the data. These loggers are set to collect data every 5 minutes. This is collecting depth, temperature, and conductivity, and turbidity. And they are operated with this solar panel, but there is a backup battery in there in case there is not enough energy produced from the sun on any given day. And so all of the data is transmitted to this online portal, and it's called Monitor My Watershed, and anybody can log on to this website here. You don't need a login, you don't need a username. It's very user friendly, and I wanted to just show you kind of how it works when you go onto the online portal. Again, I was not kidding when I said it became a hit, and they transitioned the giveaway program into a more hands-off approach, because you can see here that we have over, I think it's over 450 users that are operating the same equipment throughout the Delaware River Basin and beyond. They started to, sell these products to other organizations and other watersheds. And so once you log on, it'll bring you to, you can go to a browse site over here on, you can browse by organization. So you could type in the Nature Conservancy. You can see across, the entire, Northeast, as you just saw on that map. It'll highlight all the different sensor stations that the Nature Conservancy is currently operating. And then when you zoom in, you just click the data for this site. And the great thing about this is not only can you see the data live instantaneously, but it gives you really nice layout and analysis. And so it's really plug and play at this point, where you can look at air temperature versus water temperature. You can look at multiple loggers, multiple sensors at once. And then it also gives you summary statistics, your max, your min. You can look at a 7-day window, a 24-hour window. So it's a really nice, easy check on your sensors, are they working? But it's also a really good, easy way to manage and analyze our data. But I think one of the highlights, of this program is that it really provides great, it's a network. There's almost this support system, I like to say. And when you're out there in the river collecting this science and you have all these different pieces of equipment that often fail or go wrong, or you have these hiccups, it's really nice to be able to have so many practitioners using the exact same equipment, experiencing the exact same issues, where you can really connect with others and kind of work through and problem solve some of those issues together. And so not only have we connected and been sharing our data with this Delaware River Watershed Initiative, but locally, we've been able to use our other continuous in-stream data and leverage that, and actually give a lot of our data to some of our project partners and other stakeholders. So just last year, we began partnering with our New Jersey Department of Environmental Protection, the Bureau of Freshwater Fisheries folks, we gave them pretty much all of our data, and they were looking at stream temperature throughout the watershed, and we were able to give them our data to assess different areas that are suitable for different trout populations. And in return, they were able to actually take our data and package it nice and neatly into different data management and analysis programs. And so you can see here, they took all of our data. Again, we're collecting data every 15 minutes for 6 months out of the year, so since 2016. So we have a ton of data. So this was a really nice way to package it all and put it in one place that spit out different parameters. So surface water quality standards, we're looking at thermal regimes, different temperature changes, and just general summary stats. I wanted to zoom in. This is the Columbia Dam. This is the Columbia Dam removal site, where you can see we have a lot of different data being collected. And what the fisheries guys have been able to do for us is make, they've been able to dive in and make a deeper analysis into some of our data sets. And so you can see here, this is, from the state, something that they had found. They looked specifically at temperature, and what we started to see was pre and post dam removal. We actually started to see the temperature from the up and downstream reaches, just a year or so after we had removed the dam, start to really get to this more normal, or not normal, but stable and more natural temperature regime, where we were having this 0.52 degrees Celsius difference from the up and downstream sites pre-removal. We're now starting to see that gap close in, where we're starting to see this similar stable condition throughout that corridor. We similarly shared our data with a local resident. He is a Notre Dame student who grew up in the area and was very interested in the Columbia Dam project. We also gave all of our data over to him. He looked very specifically at dissolved oxygen. And he found similar results to the temperature results, where, pre-conditions at the up and downstream reaches, we saw these large differences in dissolved oxygen concentrations, but post-removal, we started to see those levels become a little bit more stable and a little bit closer together, and that difference really began to disappear. I do want to highlight here that this TNC 23 is actually an upstream point, and that this upstream, this gray one, is it's upstream of where the dam was, but it's closer to it's the upstream end of where the impounded area was, so that back impounded area. And so we are, really excited that not only we've been able to, get out in the river, start really making these, baseline assessments within the pollen skill, but more importantly, we've been able to really leverage the science and really connect with other partners and other stakeholders to really share the science and really work together to, figure out what are these baseline conditions, how are these projects really going to make an impact, to what degree are they making this impact. But again, this is going to take a really long time to see some of these improvements to water quality. And so one of our overarching goals for this whole program is to leave this data in the hands of our regulators and leave this data in the hands of our future scientists. So as those trees grow and in 10, 20, 30, 40, 50 years, we start to really see big changes in water quality, we'll have that pre-data from today to be able to look at in the future. And so with that, I will open it up to any questions.
There, this is Diana in Colorado. Thanks, that was great. I'm curious whether in some of your analysis you've correlated any of the data with flow and what kind of flow gauges are out there.
Yeah, so we have one USGS gauge station. It's almost in like the middle of the watershed on the main stem. And so we use flow data from there. We haven't, with the Stroud sensor stations that we just put in, those have a depth so we can start to get a better understanding of flows through the system. We, to be honest, tried to set up our own gauge stations and flow stations in some of these reaches, and it was really, really challenging. So we've just been relying heavily on the USGS gauge, and for the turbidity analysis is where we use it most. So we'll zoom into certain storms and we'll look at how the turbidity is in comparison with the flow at the gauge.
Great.
Does that answer your question?
Yeah, that's great. And I guess while I have the floor,
Yep.
Can you share anything about your annual costs, and maybe how that's changed over time with your different monitoring approaches?
Yeah, so I think probably the bigger investment was made when we first started, just purchasing all the meters. The meters can range anywhere from $1,000 to $5,000. So like the hobo loggers are relatively cheap for what they are, but just every year you have to replace the sensors and you have to get calibration solutions. So they are definitely come with a price tag. I would say on average, we probably are spending maybe around 5,000-ish a year on maintenance. But we have 16 meters plus now 3 sensors. So we have a lot going on. I think there are definitely ways to decrease the cost. I think that's another really important part of partnerships, being able to lean on your partners. And so, for instance, the state, the fisheries folks, they were going to go put out a bunch of meters, more meters into the pollen scale. And we basically said, we have it covered. We have a lot of meters out there. But what we don't have is a lot of capacity for data management and data analysis. And so we kind of traded, our data for that help. And so I think that's a really key, important part to all of this, is if you have a lot of partners, it could become a little bit more cost friendly.
Michelle, someone is asking if a similar approach has been applied to other watersheds in New Jersey, other watersheds besides Pollen Skill.
A similar approach of setting up a watershed-wide monitoring network?
Yes, that's the way I understand it.
Okay. Yes, I would say that New Jersey has a surprising number of water quality monitoring programs. There's actually a lot of different monitoring work groups that we're a part of. For each, I don't want to say each, but for a lot of the watersheds in New Jersey, there's a lot of smaller nonprofit organizations that work very closely in those watersheds, collecting data. And so we have a really good network of water quality monitoring partners in New Jersey that, even folks in other watersheds, maybe we're not collecting all the same information, but we all definitely help each other with, picking up supplies or dropping off equipment, or, leaning on one another if we have any questions. So similar studies are being conducted in a lot of other watersheds.
Okay, yeah, and I would name maybe the Musconetcong, the South Branch of the Raritan, the Stony Brook and Millstone watershed, which is now stewarded by the Watershed Institute, but there are quite a few, and luckily they do interact quite a bit. Okay, I don't see other questions in the chat. Does anyone else have any questions? Okay.
Okay, so if there are no more questions.
Okay, actually, I do see one more question. Can you share a little bit more about the siting of, oops, I lost the end of the question, of the monitoring stations, how you decided where you might position the different meters?
So the sample location was pretty dependent on, where our projects were, but we had a kind of a twofold approach. So we wanted to make sure that we were collecting data upstream and downstream of some of our big restoration sites and some of our bigger project sites. But then we also wanted to make sure that we had data coming in from the headwater tributaries. So typically we would place the sampling location at the furthest downstream point on those tributaries, so right before the confluence with the main stem. But we also actually had, so the state does collect data in this watershed, but the state doesn't collect data every year. They collect data in this watershed on every probably 3 to 5 years. And so we wanted to complement the state locations with our locations. So where we didn't have areas that were very project specific, we looked at, okay, where's the state collecting data? Could we co-locate our sites to help collect data in those gap years where they're not out here collecting data? And then we also looked at points, like I said, on those confluences of the tributaries that are coming in where maybe the state didn't have data or where maybe there were other gaps in data. I hope I answered your question.
Yep, that was from Stan, and he said thank you.
Okay, great.
Okay.
So if there are no other questions, we did want to ask you all one more question. So we had one more poll of what brought you here today. And if you could all just take a moment. Okay, great. So this is really great, and this is great insight, because what we wanted to do with the remaining time that we had, we were going to split into breakout groups, but it looks like we have a small enough group to perhaps just have a meatier group discussion. I'm looking at, because yeah, so
We have
there's
6, Michelle, so it might be just for accounting purposes.
Say that again, Heather?
We have 6 participants on.
Okay, so we wanted to get into breakout groups, but really we wanted to provide the space for networking and connecting with one another. And so we wanted to get a better sense of, folks on the call, if you're already implementing or currently using a water quality monitoring program to capture changes or demonstrate project success in your areas. We wanted to hear about them. We wanted to, really provide the space to network and connect about our science programs. So I would be okay with opening it up to just a group discussion. If anybody wanted to share maybe what they're doing or how they're collecting data in their programs, and maybe any sort of technology or any equipment that has maybe enhanced your program.
I can certainly chime in, and I guess add. Amy Singler. I sit in Western Massachusetts, out of TNC's Northampton office, and for a long time I worked as part of the Connecticut River program. Although now I'm with the global programs, and I do work both here in the US in a shared position with American Rivers, and then also supporting a number of TNC objectives nationally, and then supporting our Europe program as well. So that's me by way of a shortened version of a complicated introduction. But I do a lot with restoration and dam removal on rivers, is the shorter version. So I think this particularly for me is interesting because we almost never have the kind of funding to do the kind of comprehensive monitoring that you're talking about. I tend to work when I'm doing project level work particularly at restoration and dam removal sites. Beth, it's funny because we were just emailing in the group freshwater network today about how there's just never enough money to do this kind of monitoring and long term. So the way you've been able to structure the program and really think okay, let's get some baseline information to kind of set the stage for moving forward is really interesting. And also I think when we talk water quality, so often we're talking project specific, what does this project do for the immediate thing that you can measure? And so thinking about some of these objectives at a watershed scale, I think is also is really interesting and really, is a really nice example of the kind of forethought for that kind of work that particularly I think at the chapter level is really, is really great to see.
Thanks, Amy. Yeah, we're really excited. And I think, again, it's just really the Delaware River Watershed Initiative really allowed us that opportunity because not only did funding come through for actual projects, but there was a big water quality monitoring component because the overarching goal of that initiative was to make water quality improvements to the Delaware. And so the William Penn Foundation, who funds that initiative, also was able to give seed money to start these water quality monitoring programs.
Yeah, and they, in addition to giving funding, they did from the very beginning emphasize coordination and communication between all of the various grantees. So we do, certainly within our cluster, which is in the Highlands region of New Jersey, but even, all clusters definitely have opportunities to talk to one another throughout the year.
Do you think, actually, if I can follow up on that point, do you think that how much of this both ability to do the work and the drive to do the work do you think was driven by that fact that you had a funder who was able to really invest in that? Because it feels like so often, I mean, I'd like to say that our work is always driven by our conservation objectives, but there's the reality is that we're often sort of meandering to kind of meet funder objectives. So do you think that you could have done this work without that William Penn funding?
I would say that we would be doing the same kind of work, perhaps less of it, perhaps instead of 23 locations, we'd have, a dozen. And as Michelle said, and she can expand upon, there's lots of shared, even down to sampling and sharing, the responsibility of sampling. So not that any individual group might not have been doing a particular type of monitoring, but they're certainly able to shoulder a little bit more now. And even the communication about the kinds of monitoring tends to kind of create ideas about, newer kinds or locations of monitoring.
Okay, it's helpful.
Yeah, we've divided and conquered. So one organization will collect macros, others will do temperature in a lot of these watersheds. So it really does help. And it's also been just nice, there's certain things where we tried to collect nutrient data, we tried to collect TSS data, and we couldn't do it. So it's at that point you can go to another partner and say, do you have the capacity to do this? We really don't. I mean, there were times that we really, I think every year at some point had to realistically say we're taking on too much. We can't do all this, even though we have support and money and partners. It's not going to give us valuable data. So it's really important that what we're collecting is going to be useful and be used. With the nutrients and the TSS and stuff, it was, if we have 2 nutrient samples for the year, you can't really say how it's going to change over time, right? So we really by focusing in and using a lot of these sensors, I think that's really where the ticket is. But what I'm hoping to see, you know, we have this 10-year program, but what I would love to see, you know, post this pollen skill work, we're going to have all this water quality equipment. We're not going to, you know, we're going to take care of it. So I think we could start, you know, a program for like a citizen science program and, you know, give this, maybe not give it, but rent it or something, you know, put it to good use when we're not using it, or maybe to our, you know, colleagues in Pennsylvania or Maine or what, you know, so it's kind of nice that we have this stuff in house now. We've already made the big investment. So now we have the opportunity to share it.
This is Charles in New Hampshire. Do you think you could get just as good data with fewer monitoring points? In other words, if someone is restricted in funds, but you know, we might have funds for 4 sensors or for a similarly sized stream system, would that work? Would it give you the information you're looking for, one? And two, do you use these monitoring points as identification points as well? So if you've got, you know, an upstream monitoring site, you're getting, you know, X, Y, and Z quality, water quality parameters, but then it changes drastically. Do you do that to focus in? And I may have missed some of this, but because I was moving around a lot, but still, I just thought I'd throw that out there.
So could you repeat the first portion of that? Are you?
Yes, let's just say here in New Hampshire, we're fund poor, let's just say.
Okay.
But we want to start a monitoring program that's going to get us close to what you're getting, at least give us some really good data. Could we, and I know the obvious answer is yes, of course you could, but what do we lose by going with fewer monitors?
So I guess it depends on, are you saying you want to set something up to collect data to speak to a watershed wide baseline or a project specific? Because if you want to look at a watershed wide, like through the watershed wide lens, I think having 4 monitoring points would be obviously very limiting. And so I would probably recommend putting, you know, strategically thinking about where those points are going to give you the most valuable information. So let's say you have a farm that you know is causing pollutant loads, you know, put it in a place where it's going to show you something. So like in an area that you know is, you know, a farm field that's, or a, you know, a leaky septic, you know, where you kind of know there's an impairment and that you know you're going to do something about it. Because you can have the data, but if you're not going to do anything with it, that was kind of like when we started the nutrient sampling. A lot of our nutrient impairments are coming from our farm fields. We don't work directly with farmers, our partners do in other programs, but we, you know, our ticket is the dam removals, the tree plantings, you know, that's the work. So it's great to have that information, but what are you going to do with it was always our kind of thing. So I think by focusing on, you know, what data are you, what do you want, what's the story you want to tell? And then looking at areas that are in smaller confined reaches that help to pinpoint. So a lot of times we'll put points at like a confluence. So it's kind of like everything that's coming down to that one point, but that's going to tell you what's coming out of that tributary before it hits the main stem. If you see something coming out of there, then you can look further upstream to see, well, what's causing that pollutant load.
No, I guess maybe I I did not do a good job of asking what I'm looking for. I guess, how did y'all decide on the number of monitoring sites you wanted to have? Was it based purely, okay, we've got the money, so where can we best deploy them? Or did you have a plan where you said, I need X number of monitors to actually get the job done? I think that's more of what I mean, I understand the concept of, you know, if you've only got 4, where are you going to deploy them? But what was your plan as far as, because y'all have a lot of monitors in the system, so it's impressive. Because they are so costly.
Yeah, so we designed the points and I think we always had 22 or 23 to start, but what we collected at each changed. So we did have a private donation and a donor that was interested in this and actually helped to fund the purchase of all those water quality meters. And so it was kind of, you know, what's your dream? Where would you want to put them? And so that's kind of what got us to the starting point, because the William Penn Foundation didn't fund all of those sensors. We had a private funder. So it was,
Okay.
yeah.
I would just say that this is actually, I don't want to say an easy sell, but an exciting sell to a donor. So if you have that kind of need and you find the right kind of donor who has any kind of a science bend or a analytical, or they're computer people, you know, like there's a couple different ways you could sell this idea to someone, and they get a product, right? So every year you can show them what you learned. You can, you know, Zoom with them and show them your data, your live data, you know, so it's easier than trying to say, hey, can, you know, you help us plant 200 trees and come back in 50 years and we'll show, you know, like, so it's something to keep in mind. It is something that when you find the right donors, you can package it and, you know, I think it makes a nice proposal.
Thank you.
And I think that's how we ended up with so many. We started with 4 of those meters and somehow landed with 16 because people were interested.
I think you just lose some of the subtlety, Charles. I don't think that there would ever be too few that I would say, oh, it's not worth it. You know, like I think even if I had 1, it would be worth it. But, you know, it's just like the subtlety of your information would change. And it might even help you, you know, if you can only fund 2 and you get those 2, it might help you to figure out where numbers 3 and 4 would best go, you know, so.
Is anyone else collecting water quality data that's on with us?
Not personally or from a very specific point of view, but I keep looking at Stan's name on here. I know that he and I are both working on our TNC's water fund strategy, and I know that, you know, monitoring and evaluation from a lot of different standpoints is something that we're really trying to grow and improve. So yeah, it depends on which project and where, and yeah, with the current intent of really improving best practices when it comes to that, to measure, you know, success and what we think we know and being able to prove that, but nothing specific to contribute for me directly correlating to this project.
Just out of curiosity, what do you guys monitor? Not even if it's water quality, just.
It completely depends on the water fund. Right now we have about like 43 like completely created water funds worldwide. So in some cases it's biodiversity. Most water funds do have a water quality component. Some of them actually have a big water quantity component, but the most part is definitely a quality approach. So yeah, it really just depends on the types of things which are being measured, sedimentation, nutrients, and also the associated costs of treatment to deal with those, and, you know, the impact that conservation can have to hopefully, you know, reduce those costs downstream so that we can use that money instead to invest in the conservation upstream. I sit on this, you know, the global level of managing our water funds network, so of those folks that are actually on the ground working on it. So without my spreadsheet in front of me with specifics, I'm not sure I'd,
Totally fine. That's really interesting. Thanks.
Is anybody measuring for something that Michelle didn't mention, a component that we didn't mention?
So I'm in Colorado, and we really haven't emphasized water quality. We're really focused on quantity. and drought and, you know, not having enough water. I think also recognizing, you know, increasingly that interaction of drought and low flows and water quality, you know, certainly with temperature. You know, that's a really big deal. We had a big fish kill on one of the rivers, you know, where we've done some projects that, you know, we think was mostly a temperature low flow issue. You know, the temperature problems are generally solved by flow. You know, it's kind of tends to be less an issue of shading, although that can also be a, you know, certainly contributing factor. But anyways, so I'm just really interested, and I'm pretty new to the Conservancy. I've been here about a year and a half, to just kind of see some of these options and to just kind of broaden our thinking out, you know, if we want to be working with partners or thinking about adding in some targeted water quality, you know, it's really great to kind of see how you all are doing it and, you know, and thinking about it. I think we would probably really focus, you know, probably mostly on, you know, probably temperature and DO would most likely be what would be most important, I think, to some of our goals. So yeah, no, it's great to see this. It kind of changes some of my thinking about things we could be adding into our water program. So thank you. And there's definitely, we have places that we work where the, you know, the human recreational use, tons and tons of summer tubing, yeah, a lot of E. coli, a lot of dogs, a lot of raccoons, you know, we have some significant issues, but yeah, have you all done anything with, I'm seeing this link to the, you know, the partner thing, done anything with E. coli?
So I would just say, no, well, no, we haven't done anything with E. coli. It is kind of a beast to monitor. So there's these kits, and Beth, maybe you'll remember what they're called. They have those kits that are kind of like a quick and dirty. You can just see if there's E. coli cultures in the stream, and they're relatively, I think, cheap and simple to use, but they really don't give you much information other than, yes, it's there or not there, which you kind of already know. They're used a lot in like citizen science monitoring programs, but our partners at the Musconetcon Watershed Association, it's a local nonprofit in New Jersey, they've done really extensive E. coli bacteria studies in one of the other tributaries that goes to the Delaware. They worked with Montclair University doing an in-depth, I guess it was, I want to say like a trace ID sort of analysis. So not only where the E. coli bacteria was coming from, but the species that it was coming from. So was it a deer? Was it a dog? Was it geese? And getting really specific on who the culprit was to then go into future management. But I believe it's expensive and pretty rigorous. Beth may know a little bit more detail.
Yeah, it's called microbial source tracking, or MST. And Diana, in a situation like a lake, that's really an interesting approach, right? So if you know, you say like you have dogs and you have swimmers and you have, you know, waterfowl or whatever. So I always think that, you know, it is expensive, and you do, you know, like the sampling is meticulous, and then you have to get to the lab in a certain amount of time. But the interesting thing is, if you know, before you set out on your 3-year anti, you know, dog at the beach campaign, you better find out if it's actually dogs, you know, because it could be the waterfowl, or it could be the septic systems, or, you know, so you can find out if it's human or geese or whatever. So it is expensive, but in certain types of problems, it is important to figure out what it is that you're dealing with, especially with a public awareness campaign. Or, you know, the other thing is cover cropping, right, which prevents all of the soil running off of farm fields. Well, you know, if it's human waste, then that's not going to help your problem. If it's the manure that they're fertilizing the field with, it will. So, it can really make the difference of your approach and of your education programs. So if that's your main trouble, if E. coli or fecal coliform is your main problem, I think it's always better to go a couple levels deeper so that you understand what your real problem is.
I would also just say, if you're interested in just temperature monitoring alone, that's really easy and pretty cheap. You can get they're like little temperature meters that Hobo makes, the little pendants, and I think you can get them as cheap as $30 each. And you can throw those in, maybe not like literally throw them in, but you can place them in and leave them there. They're really not labor intensive from what I hear. We're not that fortunate. Ours are very labor intensive, but they sound like dreamy compared to what we're doing. But a lot of our partners use them, and they're pretty easy just to get that continuous data set of temperature.
I'll add too that the link that I popped into the chat about the Connecticut River sampling, that is specifically set up by the Connecticut River Watershed Association about like recreational use. So it is, I don't know the details of it, but it may be that really like quick E. coli sampling. And it's really kind of, part of it is really around public awareness. Like they have a more established water quality sampling campaign too, for some of the like hotspot monitoring around like long-term problems. But this is really like, it's sort of a public awareness, like, should you be swimming in the river today kind of thing. And they have those qualifiers on there about like what it is and what it isn't. So, I mean, that's an example of doing it in that sort of fashion, kind of the way that, yeah, as Michelle and Beth both qualified. I was gonna ask like kind of a TNC institutional SCA question, if I can.
Of course.
If I can, it might be too late in the day for some of us to take us there, but maybe it's late enough in the day. I'm curious because I feel like with all the talk within the SCA, like we talk, there's been a big focus around the intersection of water and human use, but I haven't actually heard a lot of conversations about like water quality monitoring, despite that like is like this big thing that we talk about, that intersection of, and so like water for people sort of things. And so I'm curious if you've been able to like link this, like, I mean, the sad reality, right, is that we need to link our work with those objectives in a lot of cases. And I'm curious if you've been able to do that, because I mean, this is a really holistic monitoring to hit a lot of objectives, including, sort of a lot of water quality use. So have you been able to make that, and has that been sort of successful and helpful internally for your own strategic planning? And if that question didn't make sense, just let me know, I can try again.
It made sense. I would say internally at our chapter, that was something that we really, if we were gonna make this strategic investment in the pollen skill and water quality improvements, we wanted to make sure we had the science to back it up, where we could walk away and look our, funders and donors in the face and say, look, we are tracking change and set it. In terms of like the bigger SCA, I don't think we've made like a direct connection, unless Beth, I'm missing something.
Well, we often say that, the Delaware River is a drinking water source for folks downstream. To be perfectly honest, how much of that contribution comes from the pollen skill, is, I probably fractional, but so, we can certainly say that it's, it does contribute to cleaner drinking water. We also, this watershed and, most in northwestern New Jersey are, all of the homeowners are on private wells. So there is in many cases, a very direct link between the river and their wells. I mean, I've worked on dam removals where people who lived maybe 150 feet from the river had a well that was 12 feet deep. It was, you know, way too close for a connection between river water and their drinking water. So there, you know, so there is that human health, right? And even in this river, and most rivers in New Jersey, probably most rivers anywhere developed in the United States, we are not making, you know, that fecal coliform standard for primary recreation, right? Primary contact. So while it's safe to, you know, paddle and go fishing and whatever, it's, you know, might not be as safe to get a mouthful of water if you fall in, you know, that sort of thing. So by improving this, there is, you know, the potential improvement for that human health piece.
Thanks.
Well, thank you all. If there's no other thoughts or questions, comments, clarifications, I'm not opposed to hopping off early and giving folks a piece of their evening back. I just want to say thank you so much for tuning in this evening. It's, you know, my hope that you learned a little bit more about New Jersey, and now you know who to call if you have a question about water quality monitoring and what to do and what to buy and things like that. You can reach me anytime. You have my email, you know where to find me.
Thank you, everybody.
Thank you. Really appreciate it.
Thank you.
Yeah,
Thanks.
Michelle. Beth, nice to see you.
Nice to see ya.
See you, folks. Okay, good job.
Oh my gosh, I'm gonna